Good morning. Thank you for being here. So I'm going to talk about segment routing in combination with centralized control plane. And I'll provide some view on OpenDaylight, how it develops, how it plays in SDN ecosystem. So this is where we are today. There are significant changes in networking. SDN happened. It's an ongoing process. Things are going to change in networking. But are we really going to change everything? Ways of working, the way we develop networks, the way we design networks, the way we troubleshoot networking. I think we've been there before. To many of you, this must look familiar. People who've been around long enough have seen all of this. Networking is now different. It's an industry cycle. It's normal. It will go through its hype. It will come back to normalized level. However, things are going to change. Things are going to get more programmable. There are more dynamicity in the networking. There are overall intentions to provide translation between business logic and instantiation and forwarding state. So today we are pretty much at the verge of decentralization. Where are we going from there? And why? If we look at how SDN was advertised in 2012, the main drivers were simplification, time to revenue, time to market, new services. If we look at same in phonetics research 1314, nothing really has changed. Time to market, time to revenue, optimization, simplification. Nothing really special or something we haven't been trying to achieve for the last 20 years. So the intention is to bring evolutionary path to more programmable future, not to break things. You hear a lot of talks about OpenFlow, about completely removing brain from networking devices, centralizing it. Just because you can doesn't mean you should. There are a lot of stuff we've done in IETF last 20 years to make network scale. Internet today works because it is designed the way it is. When you start bringing complexity together, when you centralize complexity, it becomes unmanageable. It's proven mathematically. By keeping things decentralized, while logically overviewing them, we provide a way to decouple complexity from forwarding. And from my opinion, again, being a networking guy, you might say you're a routing guy, so you've got some affinities with routing. But this is my view on it. The most important part is to completely decouple policy from reachability. This is how BGPLS comes into play. We are going to talk through this view on networking through my presentation. So, logically centralized, physically distributed. The systems of today, we spent 20 years on developing different protocols, on developing high availability, on developing proper O&M. It just doesn't make sense to take all these great things and throw them away. So having some localized intelligence is important. Having centralized view, having an OS being iOS, GNOS, IPOS, evolving towards networking OS is important. Ability to analyze network as a whole rather than per box gives us ability to create application-aware networking. Gives us ability to program network as a whole, not just box per box per box, having no idea whether control plane program into forwarding has same behavior as intended. So, if you look at segment routing, how does it address service provider needs? Faster time to market. The deployability of networking with segment routing through machine-to-machine interface could be brought down to minutes, if not seconds. OpEx reduction, even if we are not talking about SDN context here, gives the ability to remove LDP, give the ability to remove RSVP in particular cases. So you're, with one protocol, you've been running for the last 20 years, being SS or SPF, you know how to troubleshoot it, you know how to manage it. There are very little extensions to provide segment routing. Investment protection. if label stack is not an issue, can be used with today's hardware. So pretty much every modern router can do today between 4 to 12 labels in the stack. So only software upgrades needed, meaning you can run your routers as they are today, but making your network much more programmable. If you look specifically at packet and Opti integration, if you use IP-LDP in your network today, and you've got ECMPs and link aggregation groups, hashing is a local decision. There's pretty much no way to know which link is going to be taken. If you're provisioning optical link, ideally you would like your IP MPLS traffic to take exactly the same link. So again, with IP-LDP, there's no way to do so. Segment routing gives you the ability to pinpoint traffic to exact member of ECMP bundle or exact member of LAG group. So it provides coherent paths across network, both IP and optical. Segment routing is real, is happening. There's a working group in IETF. We've produced wide range of documents, problem statement, use case architecture. All the extensions are well documented, progressing towards working group documents. Some of them are already working group documents. Very importantly, this time we do it together. Any extensions, any change in base spec is being discussed across vendors, and we've got huge number of service provider community watching us, and in case we are trying to deviate to some vendor proprietary stuff, immediately saying, guys, it's not going to work. So we've got British Telecom, Deutsche Telekom, pretty much every tier one, besides US ones, working with us, willing to start testing. Actually, there's already some POCs and testing ongoing. So a few words about segment routing. It leveraged two paradigms. Source routing, so the way through the network is defined by the edge when packet enters the network. It's a tunnel. So I wouldn't call it an LSP as Julian yesterday did. It doesn't have to be LSP necessarily. In IPv6 case, we don't use MPLS at all. We can use extended header to provide networking. So it's a tunnel. In v4 case, there are no means in IPv4 packet to include metadata. So we use MPLS labels as metadata here. Very interesting property. MPLS label doesn't have to identify pass-through network, can identify any functions on the node, which gives us great ability to do service chaining. We are already working, in Ericsson at least, we are working on segment routing service chaining prototype, showing to you, our customers, next year. So if we take regular IP-LDP network, we've got node Z. It will advertise its own loopback. It will run LDP and advertise label to binding. So it will advertise label 65 assigned to its loopback. What we did with segment routing, we've taken this label advertisement from LDP and included it into IGP. So every router in the area would know, in order to reach node Z, I need to push label 65. So very simple. New thing in segment routing is ability to identify not only node, but also adjacency. In other words, link between two routers. So in this case, 9003, which is a label identifying link between C and O. Ability to take particular link gives us ability to do traffic engineering in source-based routing. Gives us ability to provide exact paths in ECMP or link groups networking just by pushing for label stack. So in this case, A is going to push complete label stack, identifying every link in the path, and just pop labels as we go. Very useful for O&M. So when we developed MPLS-TP, unfortunately, the idea was that O&M has to follow data, so-called state sharing. Segment routing gives us exactly the same ability without static configuration. It gives us ability to follow exact path in the network. So some, especially older nodes, have problems with deeper stacks. Segment routing gives us ability to compress stacks. So if you look at full path through the network, If you express it at number of links, you'll end up with 7 label stack. However, here, our requirements are to go from A to C, take link between C and O, and follow to Z. So we'll push label 17.2 on top, which identifies not C, label 9003, which identifies the link between C and O, and go to 65. So we managed to express full path as just 3 label stack. Today, we are pretty much focusing on transport and service edge. However, we are going into data center. There's a lot of interest to bring it into residential due to simplicity and ability to program pass through the network. And BGP, link state, segment routing extensions give us ability to glue all the pieces together, provide link between domains, link between areas, same way we did it for seamless MPLS. It provides hierarchy. This is OpenDaylight. Those of you who are not familiar with it, it's an open source SDN controller being developed by many vendors. It's a big success. It's working. It runs in live networks. In terms of development, it's probably most ongoing project today in the industry. So why we did OpenDaylight? It's really about getting wide community of people contributing to it, coding to it, taking it, using it. In terms of momentum, if you look at number of commits, it's huge. We beat pretty much any other open source project here. So only OpenStack is close to OpenDaylight in terms of number of contributors. So there's thriving community behind it. There are a lot of extensions we bring to every release. And please look into it. It's downloadable. It's open source. It's for you. There's wide industry support for OpenDaylight. Pretty much everybody whose name is in the networking is either Platinum or Silver member. There's a lot of people who contribute code, including Cisco, Ericsson, Brocade, IBM. We all contribute code on a daily basis. So, getting into OpenDaylight, so you could see there are references to IETF drafts on every slide. You can go and read in details how it works, what it does. OpenDaylight has a functionality which is BGP-LS listener. It can have connection with BGP speaker and receive all the information. We have defined segment routing extensions to BGP-LS, which give us ability to provide full topology view to the controller. Controller has a function called BGP-LS topology exporter, which can expose this topology for any user willing to take it. So this is for exposing of topology. For provisioning, PCE is natural function of every networking device. Someone has to calculate pass-through network. Someone has to support constraint-based Dijkstra to be able to provide loop-free constraint meeting path. So in this case, we use PCE and we use PSEP, which is a language used between PCE server, PCE client to provision the paths. The idea here, again, BGP is deployed. It's everywhere. PSEP is an easy protocol to deploy on top if not deployed previously. All the magic is done in the controller itself. Very importantly, it is multi-tenant. So every tenant can have its own operational view of the network. The network is represented as YANC model, so any southbound plugin. So we use PSEP. In this case, you could use I2RS, OpenFlow, any other SBI plugin available in OpenDaylight to provision your network. So the model of network decoupled from ways we provision, which is exactly my previous picture. We decouple policy from forward instantiation. Drafts you should be looking at. Stateful PCE is very important. PCE is stateful and active. It knows about every resource on the network. It knows what's being used, what's not being used, and priorities. We use active PCE, so it's instantiate LSPs. When controller receives a request from an application, I want to transport path from one node to another, PCE can go and provision this path in the network. The very important difference with RSPTE deployments, and you hear people talking, why do you need segment routing versus RSPTE? There is no state in the network. State is in the packet. Your label stack represents full path through the network. There are no refreshes recipe. It's not killing your control plane. There are some networks running today, 15, 20,000 LSPs, and control plane is pretty much loaded just due to soft state characteristics of RSVPT. Just refreshes. In segment routing, it doesn't exist. Again, as packet goes through the network, every label identifies particular action on particular node. So this is your networking graph. For sake of presentation, I'm showing you two attributes, bandwidth and delay of every link. So we are getting an application asking for path from node A, which is ingress, to node F, which is egress. It has two constraints. Mean link bandwidth should be at least 10 gig. Max delay between two links should be not more than 10 milliseconds. With the first run through our topology, we see immediately that link BD is 15 milliseconds. So we prune it. It doesn't meet our requirement. What we see then, that link where BD goes through, so ABDF cannot be used because one of the link has too high latency. So we prune the link. We identify link ACEF as viable one. We use PSAP extensions to go, again, only to ingress router. We don't touch any other router. We provision the link CEF, CEF. We are ready to start service. So through machine-to-machine interface, in this case from application, there's pretty much no human involvement. You can provision paths, you can provide admission control, and you could do this per application. It's multi-tenant. And there's always your LSDB in centralized PC, which knows usage of resources, which knows who should be protected, which way, and provide full service. So next application might come with very different requirements. Again, I want a path between A and F, but in this case, I don't really have any requirements with regard to delay. However, I want to use more bandwidth than available on single link. So normally, you would say, no way, I cannot provide single path because there's not enough traffic, not enough bandwidth available. However, in segment routing, what we could do, we could use label identifying not path to particular interface, but as hashing function, which will result into load balancing. So it gives ability to do not eCMP, but UCMP, provide weighted load balancing. So what we are going to do, there are two LSPs we could use to provide bandwidth available, and there's enough bandwidth. Then what we are going to do is to provision single label identifying hashing function on node A, and establish two LSPs. So again, we couldn't do this before. It cannot be done with RSVPT. Here, we can provision more. We can over-provision our network to some degree and get more money from the network we have in place. Re-optimization. So very simple case, which shows link overloading, but I mean, every vendor is building analytics into their devices. So very soon, you are going to have constant stream of details from your devices saying memory usage, any usage. So in my company, we are building kernel model which will provide real-time kernel details to analytics system. So in this case, what I see is that this link is overloaded. So normally, I would need to go back to transport department, ask for another link. However, here, I've got all my information. I know priority of the links in LSDB. So I'll identify there's another link available, which matches the priority of traffic I'm sending to. I'm going to download information about this path, in this case, BDF, and then make before break fashion, reestablish new LSP. So it's pretty much self-healing network. It reacts on failures, and actually it can react on pre-failure. So if I see memory growth in particular process without any changes in topology, there's either memory leak, maybe I'm under DDoS attack, something is going on. It gives me ability to react on potential failure network before it happens. OpenFlow and IP networking. If you look at today's interworking, there's pretty much none. From OpenFlow perspective, any IP device is just a remote endpoint. It has no idea how to get there. It has no idea how to provision end-to-end O&M. Another point, from routing perspective, all OpenFlow devices are represented as single layer 2 hub. Needs two different kinds of O&M, needs gluing in between. Same problem as MPLS-TP pretty much, when one part of network is statically provisioned, another one is dynamic. However, using toolset available in segment routing and SDN controller, what we could do, imagine again, yet another application is coming and asking for path between OpenFlow switch 1 and router 3. So what we already know, we know labels assigned to all routing device. Controller knows about them through BGPLS. We've built some additional logic to OpenFlow, so when OpenFlow channel is established between controller and the node, we will assign label to every node, pretty much same as loopback in IP domain. We will assign label to every port in OpenFlow domain. Very importantly, we can advertise back those labels and identifier to IP routing domain. So when I want to establish LSP from routing domain into OpenFlow, I already know which labels to push. So in this case, flow goes from OpenFlow domain to routing domain. So what we provision is, we mention particular FAQ, which is basic function OpenFlow. We push particular label identified to no, which is very basic functionality in OpenFlow. We also need to provision every node in OpenFlow domain because OpenFlow doesn't have any control plane. So what we will provision is really swapping labels here. We know label 13 identify our egress point, so we'll use it here. We will swap it. At the moment we get into routing domain, we already know label 13 identifies router 3. We'll go to router 3. So it gives you end-to-end visibility into a network, gives you end-to-end O&M, gives you single LSP. Optical. So as we talked before, when you provision optical resources, you would ideally like your IP MPLS traffic to take exactly path you have provisioned in optical. Again, with the CMP, there is no way to do so. Provisioning link adjacencies in segment routing gives you ability to follow exactly the same path, gives you ability to integrate Opta and IP using, for example, IPFRR, which is much cheaper way to provide high availability than optical recovery, which is much slower as well. So to IPFRR story specifically, if you're familiar with loop-free alternative, it's topology dependent. In particular topologies, there's very little or no coverage. Remote LFA on top could help, especially in rings. However, again, there are pathological networks where there's no coverage. Segment routing gives us ability to tunnel traffic to point of local repair. So it provides IPFRR with 100% coverage in any topology. In terms of algorithmical work, it's pretty much like remote LFA. It just tunnels traffic to the point of local repair. So when you combine it with Opta domain, you can immediately stop using recovery in optical and rely on IP MPLS recovery, which is as fast. In good implementation, you would see recovery in sub 10 milliseconds. Use case we are working on with Tier 1 in the US. So their network and requirements, today's core, today's optical, it's pretty much Cisco Juniper. So what they're saying, you know what, we don't want you to touch it. It's there, we've invested billions of dollars into it, it has to stay where it is. They're deploying data center all over US, and they decided to use OpenFlow as technology to populate forwarding. So what they're saying, we would really like to be able to provision pass through the network from our data center without touching core as such. So when we take all the requirements, what we see, we can expose topology of the network through BGPLS. It's already available. It's very easy to provision segment routing stack through OpenFlow. It's pretty much push label, next table, push label, next table. It gives us ability to provide full story where data center is in charge of provisioning network without touching the network. So could be as simple as OpenStack asking for connectivity between two VMs and two data center, and transport controller provisioning the path through Opta and IP MPLS domains. So we are working on this story. We are working on proof of concept for next year. Hopefully, you'll see it very soon. So more information available in IETF. It's the right place to use. The new working group in charge of segment routing called Spring. All the extensions are defined in OSPF working group for relative routing protocols. If you look at BGP, PSAP, some other, all these extensions are available. Most of them are already working group documents, so please go read them. They're quite stable. I would expect first implementations to be on the market next year. Questions?
I was missing a part of edge. So how is the edge going to be realized? I mean, is the node on the edge will be aware of all this concept and communicating directly with the controller, or it will just have to send a packet to the edge node, which will take decision about forwarding?
So SDN provides ability to calculate paths centrally. However, it's not really needed. You could just replace LDP with segment routing and work as before. You'll just get an LSP provision.
Yeah, I was wondering if this, for example, in a data center, if there could be a server which could communicate directly with the controller, and at the server could add the proper stack of labels to forward the packet to the network.
Absolutely.
Then even the IP addressing doesn't matter anymore, which is, if you have overlapping addresses or whatever, it's just tunnel.
This is the intention. So why did we do MPLS in first place? To decouple location from address itself. You don't want to look up IP address every time you forward packet. You want to do label based. So you have your LFIP in, out. All
but
you
still
do.
On the edge, it was done. On the edge, label edge routers.
So here at the edge, you push down full stack identifying pass through the network if needed, and your tail end.
Yeah, I was wondering if it's possible to move this function to the server directly.
Absolutely. So if you look at Deutsche Telekom use case, this is exactly it. They would like to use segment routing for troubleshooting, meaning they've got their working station. You can identify where you inject the packet, where it goes out. And this is done by a server. So it pushes stack which identify to a particular node they would like to change connectivity between. So this is exactly your use case.
And for V4, MPLS is necessary. For IPv6, as I remember, it's not a problem because it's additional header.
So for V6, you could use both. You could still use V6 LDP, V6 SR, and MPLS encapsulation, or you can just use native V6 with extended header to provide full.
But you just analyze the header without the, without the IP addresses. In fact,
it's just it just identifies next link or next node.
Okay, thanks.
Thank you for your presentation. I do appreciate the use case that you have explained to us. I have several questions. I have noticed that you are using Ericsson SDN controller. Is it based on OpenDaylight project?
Yes, it is. It is OpenDaylight, hardened by Ericsson.
Okay. And my second question is that in the first case that you've shown that your controller is already able to kind of make centralized route decisions based on delay or bandwidth uses. So along with your controller, you already have this kind of intra-domain monitoring or measuring applications along with?
So information is derived from the network. There are extensions to both ISPF and ASIS called extended metric. They're going through last call as we speak. And this information is distributed through BGPLS to the controller, and controller could take this information into PC computation.
And I think the solution works well for those routers with BGPLS support. But what if for pure OpenFlow switches, for example, how are you going to capture those informations in network? So
I had a slide about OpenFlow. This is my answer to you. I don't think OpenFlow is the right technology to be used in the WAN. It's too disruptive. It doesn't bring any value as it is today at 1.4. So there are too many extensions. still need to be defined, need to come to provide high availability, carrier greatness, proper O&M to begin with.
My final question is about how you operate the network in a hybrid environment, which that is in your third and fourth case. In the third case that you showed hybrid environment, you have an OpenDaylight domain, and aside you have a segment routing domain, and the next case you're explaining is kind of US tier 1 cases. You're also using a kind of hybrid environment. In that environment, my question is that you are kind of mimicking segment routing behavior on pure OpenFlow switches, like giving them labels. But my question is, why doing that? I think the labels only have meanings to segment routing area, and for OpenFlow switches, they can just kind of forward a packet according to the OpenFlow flows, you know. So just my.
So.
I want to know how you justify to make OpenFlow switches work like traditional routers in terms of MPLS forwarding plan.
It's a very valid question, absolutely. So the answer is market. 98% of the networks today are MPLS. So OpenFlow is coming here and there, and requirement number one is backward compatibility. How those two networks work together. So if you look at OpenDaylight specifically, there's a model called FRM in charge of OpenFlow. We are working with Cisco to extend it to support exactly functionality I've shown you, where you assign label to OpenFlow switches and ports.
Thank you very much for your response.
My pleasure.
Are there any other questions? If not, then thank you so much for your presentation.